Assalamu alaikum guys, I am Gazanfar Ali, your chemistry tutor, and last time we discussed about the conformational analysis of monosubstituted cyclohexane, 1,1-disubstituted cyclohexane, and some special cases of 1,1-disubstituted cyclohexane. In this video, we are going to discuss about the conformational analysis of disubstituted cyclohexane. We have three cases. One is the 1,2-disubstituted cyclohexane, 1,3-disubstituted cyclohexane, and 1,4-disubstituted cyclohexane. As we know that due to restricted rotation in the cyclic systems, the alicyclic compounds show geometric isomerism or cis-trans isomerism. So here we can see that the disubstituted cyclohexanes also show cis-trans isomerism. Due to restricted rotation in cyclic system. So 1,2-disubstituted cyclohexane, 1,3-disubstituted cyclohexane, and 1,4-disubstituted cyclohexane show cis-trans isomerism or geometric isomerism due to restricted rotation in a cyclic system. So how we assign them cis or trans isomers? Here you can see if the bond is axial up, equatorial up, equatorial up, axial up, equatorial up, axial down, equatorial down, and equatorial down and equatorial down, then we assign them cis isomers. Simply we can say that if both the groups are in the upward direction or in the downward direction, then we assign them cis isomers. And if the bond is axial up, equatorial down, equatorial up, axial down, equatorial down, axial up, axial down, equatorial up, then we assign them as trans isomers. And we can say that they are trans isomer if one of the group is in the upward direction and other in the downward direction. So here we can see that there is up, 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 down, 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 down. So if the groups are in the upward or in the downward direction, then they are cis isomer. If one is up and other is down, if one is up, other is down, if one is down, other is up, if one is down, other is up, then they are the trans isomers. So this is the system. So how we assign cis and trans isomer to disubstituted cyclohexane? If the both groups are in the upward direction, in the downward direction, then they are cis isomer. If one group is upward direction, other is in the downward direction, then they are trans isomers. First of all, we will discuss about the 1,2-disubstituted cyclohexane. So it is our cis, because both the methyl groups are in the upward, above the plane, so it is our cis 1,2-dimethyl cyclohexane. So in chair conformation, we draw this structure like this. So if one methyl group is at axial position, axial up, and other is in equatorial up, then they are cis isomer. So it is our cis isomer, and there is a hydrogen at the equatorial and hydrogen at the axial position. So when we flip this chair conformation, we get another chair-like conformation like this. Now we will observe that this axial up is converted into equatorial up, and this equatorial up is converted into axial up. So here we will observe that this is axial up methyl, this is equatorial up methyl, and we said if both these groups are in the upward or in the downward position, then they are cis isomers. So both are the cis isomers. So this methyl group is axial up, this methyl group is equatorial up. So it is our AE conformation. In this conformation, we will observe that this is methyl group is equatorial up, this methyl group is axial up. So it is also EA conformation. So we know that there is a axial hydrogen here, axial hydrogen here. Similarly, there is a axial hydrogen here, equatorial hydrogen here, axial hydrogen here, axial hydrogen here, and equatorial hydrogen here. Now we see the stability. We know that methyl group is a bulky group and these are the diaxial hydrogens. So there is 1,3 diaxial interaction present between the one methyl group and the two diaxial hydrogens. So there is 1,3 diaxial interaction present in this conformation. Now in this conformation, that is the EA conformation, we will observe that so we will observe this is a bulky methyl group and this is a axial hydrogen. Here is a axial hydrogen present. So due to the 1,3 diaxial interaction present between one methyl group and two diaxial hydrogens, the stability of both conformation is almost same. We say that stability of EA is approximately equal to stability of EA because there is only 1,3 diaxial interaction present in both conformations. Now we draw the trans isomer of 1,2-dimethyl cyclohexane. One methyl group is represented by the wedge bond while the other is represented by the dash bond. So it is below the plane, this is above the plane, so it is our trans 1,2-dimethyl cyclohexane. So there is axial bond, equatorial bond, axial bond, equatorial bond. Similarly, axial, equatorial, axial, equatorial. So if one methyl group is axial up and other methyl group is axial down, then this conformation is called AA conformation. In this conformation, this axial up is converted into equatorial up, this axial down is converted into equatorial down. So we will observe that there is a axial hydrogen here, axial hydrogen here. Similarly, there is a axial hydrogen here, hydrogens, and other is the 1,3 diaxial interaction between this methyl group, these two diaxial hydrogens. So there are two 1,3 diaxial interactions present in trans 1,2-dimethyl cyclohexane AA conformation when both methyl groups are at the axial position, but in EE conformation in which both methyl groups are at equatorial position and there is no 1,3 diaxial interaction present. So due to the absence of 1,3 diaxial interaction, this conformation, that is EE conformation, is the most stable conformation. In this conformation we see there is only one 1,3 diaxial interaction present, there is only one 1,3 diaxial interaction present. But in this conformation, we will observe that there are two 1,3 diaxial interactions present. So we will observe that the stability of AEE is greater than stability of AE, that is approximately equal to EA, and the stability of EA is greater than AA conformation. This is the order of stability. And we will observe that this methyl group is axial up and this methyl group is axial down, so it is our trans isomer. Similarly, in this conformation, we will observe that this methyl group is equatorial up and this is equatorial down, so it is our trans 1,2-dimethyl cyclohexane. So this is the conformational analysis of 1,2-disubstituted cyclohexane. 1,3-disubstituted cyclohexane. So this is 1, 2, and 3. And both methyl groups are represented by the wedge bond. Both are above the plane, so it is our cis 1,3-dimethyl cyclohexane. And in chair conformation, there is a methyl group at carbon number 1, 2, and 3. And at 3, we will observe that this is the axial up and equatorial down. How they become cis? If both methyl groups are represented by axial up bonds, then they become the cis isomers. So it is 1,3-cis-1,3-dimethyl cyclohexane, and we will observe that there is a 1,3-diaxial interaction present. There is 1,3-diaxial interaction present between this methyl group and this methyl group and this hydrogen, this methyl group. As we know that the methyl groups are the bulky groups, so the steric repulsion produced due to the interaction between two methyl groups is greater as compared to the steric repulsion due to the interaction between one hydrogen and one methyl group. So the stability of AE is least due to the steric interaction between between these two methyl groups and one methyl group and one hydrogen. So when we flip this molecule and get another conformation, the axial up bond is converted into equatorial, axial up is equatorial up, and at carbon number 3, the axial up is converted into equatorial up. So this is our EE conformation. And we will observe there is no 1,3-diaxial interaction present in this conformation. There is no 1,3-diaxial interaction present in this conformation like this conformation, where there is a two types of interaction present. One is between this methyl group and this methyl group, and the interaction between this methyl group and this hydrogen. So it is least stable, and due to the absence of 1,3-diaxial interaction, it is the most stable conformation. Now we draw the trans. It is trans 1,3-dimethyl cyclohexane. Axial bond, equatorial bond. So we draw the trans conformation. One is up, other is the down. So one methyl group is in upward position and the other is at the equatorial down position. So it is our AE conformation. And when we flip this conformation and get another chair-like conformation, there is a, this is our carbon number 1, 2, and 3. So our axial up methyl group is converted into equatorial up, and this equatorial down is converted into axial down. So it is our EA conformation. So in this conformation, we will observe that there is a two diaxial hydrogens present, and there is 1,3-diaxial interactions present between this methyl group and these two diaxial hydrogens. There is 1,3-diaxial interaction present that reduces the stability of this conformation. While this methyl group is at the equatorial position, so there is no 1,3-diaxial interaction between this methyl group and any other axial hydrogen. So in this conformation, we will observe that there is 1,3-diaxial interaction present between this methyl group and these two diaxial hydrogens. this methyl group, and with these two diaxial hydrogens, there is 1,3 diaxial interaction present. While this methyl group does not show any 1,3 diaxial interaction with any axial hydrogen, so the stability of EA and AE is approximately equal to each other. So now we discuss the order of stability. Order of stability. Equatorial conformation is more stable as compared to axial equatorial. Axial equatorial is approximately equal to equatorial axial. We will observe that there is a steric repulsion between one methyl group and this methyl group, and one methyl group and hydrogen. So both methyl groups are axial. At the axial position, there is large steric repulsion produced due to this conformation. So it is our cis and it is our trans, because one axial up and other is equatorial down. One is equatorial up, other is axial down. So this is the 1,3 disubstituted cyclohexane conformational analysis. Now we will discuss 1,4 disubstituted cyclohexane system. So there is a methyl group that is represented by the wedge bond. So it is cis-1 for dimethyl cyclohexane, and its chair-like conformation. At carbon number 1, there is a methyl group in the upward position. At carbon number 4, there is a methyl group at equatorial up position. So it is our cis, because one methyl group is axial up, other methyl group is equatorial up, and there are two diaxial hydrogens are present here. So there is a 1,3 diaxial interaction present between this methyl group and these two hydrogens. So this conformation is less stable as compared to equatorial conformation. And in this conformation, when we flip this molecule, we get another conformation in which the axial up methyl group becomes equatorial up, and the equatorial up is converted into axial up. So there is a 1,3 diaxial interaction present between these two diaxial hydrogens and this bulky methyl group. So due to the steric repulsion between one methyl group and two diaxial hydrogens, this conformation is less stable as compared to equatorial conformation, and the stability of AE is approximately equal to EA, because there is only 1,3 diaxial interaction present in this molecule, and there is only 1,3 diaxial interaction present between one methyl group and two diaxial hydrogens. Now we are discuss the trans 1,3 dimethyl cyclohexane, trans 1,4 dimethyl cyclohexane. So in chair conformation, there is a axial hydrogen here, axial hydrogen here. We draw the trans. At carbon number 1, there is a methyl group at the axial up position, and at carbon number 4, there is axial down methyl group. So it is our trans, because one methyl group is axial up and other is axial down. When we flip this conformation and get another conformation in which this carbon, this methyl group becomes equatorial up, and this methyl group becomes equatorial down. So this methyl group is axial up, this methyl group is axial down. So it is our trans 1,4 dimethyl cyclohexane chair conformation, and this methyl group is equatorial up, this methyl group is equatorial down. So it is EE 1,4 dimethyl cyclohexane. So we will observe that there is a 1,3 diaxial interaction present between this methyl group and this hydrogen, this methyl group and this hydrogen. Similarly, there is 1,3 diaxial interaction present between this methyl group and this hydrogen, this methyl group and this axial hydrogen. So there are 1,3 diaxial interactions present in AA conformation of 1,4-dimethyl cyclohexane. So no 1,3 diaxial interaction present. So this conformation is a stable conformation, that is the equatorial conformation. So now we conclude that the order of stability, equatorial stability is greater than axial equatorial stability is approximately equal to equatorial axial, and the stability of this is greater than axial. So this is all about the conformational analysis of 1,2 disubstituted, 1,3 disubstituted and 1,4 disubstituted cycle.